Okay, not an issue. So I'll just give you a quick wrap up. So we had two classes before. So on the initial class, we were speaking on the course structure a bit, and then we followed up with what is DevOps and what are the DevOps principles, and then the metrics we need to follow when we are working with DevOps, right? Maybe we can once again later touch base on that, but moving a bit ahead. And yesterday we spoke about or discussed why cloud has become now so much important in the DevOps culture, right? And we had listed out, if you can see my screen, right? We have listed out few major advantages of using cloud, right? Be it on-demand service, broad network access, then multi-tenancy, cost optimization, and scaling and elasticity, right? These were the major advantages of using cloud over on-premise instances, right? Apart from that, we also spoke about a bit more detail about scaling. So scaling was can be divided into two parts. One is horizontal scaling and one is vertical scaling. So horizontal scaling is scaling or adding more instances or keeping out instances based on your traffic. So we termed it as scale in or scale out. So scale out basically meant adding more instances, and scale in was removing the instances. While we had also seen vertical scaling. So vertical scaling meant was adding more specific instance specification or increasing the configuration of the resource that we are using, and based on that we can also reduce that, right? And later on we discussed the OSI model, right? uh, so what is the OSI model that the entire IT backbone is standing upon, right? There are seven, uh, eight, I would say now, uh, levels that we need to follow, even if we are doing anything on cloud. So it stands upon it's a bottom down approach. So we start with networking, then storage, then servers, then virtualization, OS, middleware, runtime, data, and application. And these can be again segregated into the major terms that we learn nowadays as IaaS, PaaS, and SaaS, right? So if I just tell you quickly that IaaS stands for infrastructure as a service, and this comprises of the networking, storage, servers, and virtualization, which and also OS to some extent, but these service mainly in cloud terms or GCP terms, if you say, it consists of the VMs, the cloud storage, the VPCs. These fall under these services, right? And then we have PaaS, platform as a service, which constitutes of runtime, middleware, and OS. These are mainly uh, the where we get an entire environment set up and we don't have to control the environment. Only thing we have to think about is our own data and application. So that those services fall under platform as a service or PaaS. And those typical examples, if you think in terms of GCP, would be Cloud App Engine, the GKE, cloud functions. These would be the ones that fall under it, right? And then comes the SaaS, right? The software as a product. We get the entire set or entire software to use, right? Those would be Gmail, Dropbox, Zoom. So this is the fundamentals of those services that are there in the market, and the backbone stands on these eight layers, right? So we talk about that, and then we focused a bit on what are regions and availability zones and edge locations, right? So this was a quick wrap up for you, Shruti, and for everyone else who have joined in. Today we would be speaking a bit on the networking part, right? So networking becomes the very first backbone of the any infrastructure which you use. So how to use that and how to set up your own network before you use it, and how do you do that on GCP account? And that's again is the most fundamental thing that we're focusing on today, right? Just a quick question. Does everyone have now their own GCP accounts to do their practicals? Is the PPT visible to you guys? Because yesterday I forgot to share that and then I went ahead and when explaining that. Is it visible? Just put a yes or no quickly. Is the PPT visible, guys, as well as the screen of the drawing.io?
Yes, it's visible.
Okay, great. Great. Okay, so why do we need networking, right? So it is the most fundamental thing for any communication, right? Let's say, just think of in simple terms, right? If you have to talk to a friend, you are sitting in Delhi and you need to talk to a friend in Bangalore, you need a device to communicate, right? So that might be earlier we used landlines, now we use telephones, right? Or mobile phones, I would say. So likewise, same, if you want to communicate with one application to the other application, there has to be some source or some protocols that we need to follow while we are doing establishing that communication, right? So basically, we generally try to communicate on IPs, right? What are IPs? IPs is Internet Protocol. We all know that. And these are the fundamentals thing that we all are aware of, right? I'll not go into that deep, but if you have any questions later, I can take that up. So we communicate on IPs, right? So there are two types of IPs. If I can tell you, let me quickly write it down. It will become easier. IPs. Then there are two type of IPs, private IPs and public IPs. Okay, so what do I mean by private IPs? Private IPs in term means the IPs which are cannot be accessed from uh, the internet, and it is used for our internal communications, right? So let's say in my house, when I'm talking to my mother, just I'm giving an analogy. So when I'm talking to my mother, my neighbor outside, if I have all my doors and windows closed, they cannot hear us, right? So that is how you can just think of a private IP, is that when two applications or two servers are trying to communicate within among themselves, outside internet appliances cannot listen to them or cannot talk to them, right? Until and unless they are given certain privileges to do that, right? So that big falls under private IPs. The second would be public IPs, right? So public IPs are generally used for internet access. These are used to communicate with your external wall, right? Yeah, definitely there are multiple ways how to set that environment up to communicate. That's another prospect of it. We'll see into that. But just on a higher level, just think of that private IP is used for internal communication and public IP is used for uh, external communication. There's and also one more thing which you also need to know about of here is static or elastic IPs. So this is again a term that has been introduced into the cloud infra. I guess. Okay. So what do I mean by static and elastic IP? Is let's say when I am setting a VM, right? When I'm spinning up a VM, in that way we can tell that VM that hey, please use a public IP. Okay. So it will spin up getting a public IP so that we can from our external world we can communicate using that public IP with that virtual machine, right? But there is a problem to that, right? So when we will be working with VMs, we'll get that complete hands-on on what the exact problem I'm talking about. But let's take it on a higher level right now. So once we first do the setup, we do get a public IP to communicate if we have that checkbox ticked that allow public access, right? But if I let's say terminate that machine and then once again spin that up, right? So what happens that public IP that automatically gets deleted and a new public IP is again assigned to it, right? So in one way it does not affect you much, because if you are doing it on a very low level POC or a very low level your own learnings, right? But if you are giving that public IP outside to your clients, right? So every time your client cannot, you cannot give your client every time a different public IP to communicate with your servers, right? That becomes a headache for them also and for you also, right? So have to have that public IP static, right? So you can get those static public IPs. There is a way of doing that. You can get those static public IPs, which also is known as elastic IP in some terms, and also known as in GCP they call it static IPs. And you assign those to those machines, right? Instead of taking arbitrary or ephemeral public IPs, you directly assign them these static IPs, and then they remain constant uh, in any sort of patching or terminations or restarts when you do that to those machines, right? So this is on a higher level. What do I mean by private, public, and static IPs, right? Any questions? Yes, no, maybe.
No.
I'll Okay. I'll take no as an answer. Thank you. Uh, okay, so as I was telling you, right, why there is that private IP, public IP, and static IP, right? So now think about a situation, right? You want to keep your uh, communication between your internal applications, let's say the applications that are running in GCP, uh, to be private, right? How can you do that? In your on-premise, you if you have worked on on-premise, then let's say you can set up your own firewalls, then you set up your own routers, then you set up your own networks to do that, right? And then you set up proxies and whatnot, right? So the same thing you can do it in terms of VPC. That is the backbone of the networking in GCP cloud, right? So VPC stands for virtual private cloud, right? So let's say I'll take an example over here. I have quite a few examples. Let's say you don't want anyone on the internet see the data exchange between the application and the database uh, that is running in your corporate network or your on-premise data center, right? So is that possible to do? I would say yes, because they have their internal mechanisms, as I was telling you. They can set up their own routers, their own firewalls, their own proxies. And again, if you do not want, let's say you are running few applications and you do not want any other internet related applications to communicate with your application or your database, right? So can that also be done? Yes, that can be done using multiple, again, ways to do that. You can set up your own routes, you can set up your own uh, firewalls again to do that, and again you can do the same procedure here in cloud, right? And but the one most biggest advantage what you get over here when you do that in cloud is your hassle to do that is gone, right? Once you do that setup, it's a very quick setup that you can do and you can think it analytically. And once you do that setup, you don't have to again go back and maintain those independent resources that they get created internally, right? That's the biggest advantage that you get over here in cloud, right? And then cloud does do your entire takes care of your entire security and management, right? Once you have done that setups. Okay, let's go move ahead. So I had just answered you. So how can you do create your own private network in the cloud? You can use VPCs or virtual private cloud, right? So let's talk about a bit on VPCs, right? So what is a VPC? VPC is an isolated network in GCP cloud, right? So if I just go to the cloud platform, so if you are using a GCP account, the first thing, as I also spoke yesterday about a bit on the organization projects and folders. So you definitely must have now created your own projects, because that is the first fundamental thing that you require when you are working with GCP. So if you have not created, please go ahead and do create your own projects so that you can work with resources, right? Otherwise, you won't be allowed to do that, right? And if you have any doubts related to that, you can later ask me. Sorry. So I have my own project created, and also I do have my billing account that is attached to this project. So how to go to this VPC? There are two ways you can find this VPC on your cloud portal. One is you either go via the left and very handy and very self-explanatory dashboard that they do give you, and you can find VPC from there and then go there. And otherwise, a quick way of searching would be you type in VPC. It does give you what is a service that you want to use under VPC, and you can directly go there, right? So this is a quick way of going through and hovering around, right? So here is what we find a VPC, right? Okay, now let me just go back. So what is a VPC? A VPC is an isolated network. So whatever communication happens inside a VPC is very much internal, and no one, unless and until specified, I'll again once again use the word until and unless specified, cannot uh, come in to my own private VPC and communicate with my resources that are lying under it, right? So if this examples are a bit harder for you, please do stop me and let me know so that I can give you more simpler examples to help you to understand. Because in general terms, this might be a bit tricky for you when if you're hearing it first time. And just believe me, guys, you whenever you are doing or working for any client, there will be a scenarios where you have to set up your own VPCs and subnets, right? I'll talk about subnets and all other things. So take a very minute uh, or just try to understand these concepts, right? This is very important when you are doing the setups. Okay. Yeah. So as I already told you that network traffic in within a VPC is isolated, means it is not visible from all other Google other internet traffic or also other VPCs that get uh, created inside your project or other organizations until and unless specified, right? I will also we have when we do the demos, I'll also give you live examples of this entire line that I just spoke to you, that it is not visible also from other Google Cloud VPCs, right? Until and unless we give those privileges. Okay. So again, why VPC is so much important? Because VPC we can control all the traffic coming in and also going out, right? And just a few other pointers is that if you want to just write the terms just for your own research post these sessions, you can just take those terms and just do a open learnings, because you don't have to write down each topic, because near to the end of the course I'll share the entire PPT, so that your time is also saved and you can focus only on the learnings and understanding the concepts and doing the practicals, right? Don't have to write down each and every line. I'll definitely share the entire PPTs. That is why it is prepared by me. Okay. Apart from that, all your resources, whenever you are spinning up, let's say a compute or a storage or a database, you definitely need to keep it inside a VPC. That's a mandatory way work or a mandatory step that you need to follow. Okay, another most important term if is the VPC is a global resource. What do I mean by global? Yesterday we were speaking of regions, and uh, I'll just quickly give you a brush up if anyone has joined in, so he or she also understands. I'll just take it on a high level. Okay, so what do I mean by VPC is a global resource? Means we have multiple regions where our data centers are sitting in our GCP's entire cloud infrastructure, right? So for now, this number has increased. It is now less nearly 39, I would say. Did it go? Okay, let's not disturb. It's now 39 regions where VPCs or the cloud infrastructure regions are there. So if you can think of as US East, US West, in India, I won't say India, they cover it as APAC countries. Then you have in UK, in Africa, in Australia. So in multiple regions, they have their data centers sitting, and they term those as regions, and they again subdivide those regions into multiple subnets. Oh, sorry, in availability zones, right? So that even if, because why they keep it down to zones, because let's take as example of India. So India is a very big country, right? So if a person sitting in Chennai and trying to access a data center where the applications data is stored in Delhi, so there can be uh, a latency or very less throughput, right? What do I mean by those terms? If you have any doubts, if you have not joined yesterday, we can talk about it later. But let's take it high level. So there's very latency, there's much of latency, and there's less throughput of data that is flowing, right? So for that, to solve that problem, again GCP has subdivided those big regions into other strategic settings, where they have put those data centers as close near to the users that are strategically located near to them. And that is what he meant by availability zones, right? So VPC is a global resource, means it is not specific to any location or any region, right? So it's basically a global resource. Unlike if you have someone has used a VPC in AWS, you get to first select a region for your VPC, let's say US East, or if you are using India, you can use a Mumbai region. But here, you don't have to do that hassle, right? It's a global resource, but there is a segregation again to that. Yes, that how can we select again? You might be wondering, how can we select again those regions? We we solve that using subnets. Okay, so what is a subnet? So let's take an example again. So first difference would be over here in terms of GCP, VPC. Let's take an entire house. Let's take an entire building as a VPC, and each building will have multiple floors, right? Let's take if you think of an example of a 21-story building. So that 21-story building, just think it of an entire VPC, and let's say floor 1, floor 2, floor 3 to up till floor 20 is one each subnets, right? So what we have actually done to that entire building is we have segregated those buildings into multiple chunks of floors, right? So that is what you can think of in terms of VPCs and subnets. So VPC is a big division, and subnets are small parts of that VPC, right? So here, how do we divide that? Because VPC in GCP is a bigger or a global resource, so we don't have that advantage of taking out regions or giving it regions. So for, let's say, first floor. Just to give you an example, just don't think it live. So the first floor becomes, let's say, the Asian region, right? And then that region will have again its subnet, its availability zones under it. And then second floor may be some UK, EU Central, right? And the third floor can be US East, right? So just think it of that way. In this way, they are segregated, right? But if you have used other if you have used AWS, then you can just think it of in that way, that you have a bigger range of IPs, and then you just do a segregation based on those IPs. You just take small chunks out of those IPs, and then that is how the subnets are created. But in GCP, as I told, subnets are mostly created based on the regions, what you require, where your resources to be hosted. That is one of way of identifying or thinking about subnets. The other way around would be, let's let's think of an example. I was telling you, right? We can have multiple resources, right, in our GCP network, right? And those resources we want to, let's say, keep okay. I'll just finish this. So we want to think of that. We want to keep few resources which should interact with our internet, and few resources which should be actually private to us, and they should not communicate with the internet, right? So let's first quickly, let me take an example over here. I have a quick example. So I have three resources. One is a cloud load balancer, one a compute engine, another a database, right? So my criteria over here is my cloud load balancer should communicate with my internet users, but my compute engine and my database should not communicate with the external internet user. Means my external user, even if they try to communicate directly with my database, they should not be allowed to do that, right? So how can we do that? So this is where again subnets help us to. Subnet is the first primary thing that helps us to solve this problem, right? Yes, there are multiple other supporting components to it, but as we go on, I'll speak up with others of the other components also. But firstly, subnet do help us to do this segregation, right? So how can we again define that? We again can spin up or create two different subnets. One we can call it a public subnet, and the second one we will call it a private subnet. So my, as you can understand with the names, my load balancer will now sit in my public subnet, which will communicate with my external user sitting into the internet, and my private subnet will keep a host of the resources of my compute engine and database, right? And they will not be able to communicate with my external internet user, right? But there is again a catch to it, is that my load balancer, which is sitting on my public subnet, will be definitely can communicate with my private subnet resources, given the permissions are proper permissions are given to it, right? That is one thing that you need to know it on a higher level. When I go ahead with the demos, that is where the things get more clear. But this you need to just you have to think it and visualize in this way. So there is a private subnet and there is a public subnet. Okay. Any doubts up till here? I think it's a lot going in. Uh, please feel free to ask anything related to it. I might be able to answer. Hello. Uh, any question, guys, that's coming to your mind?
Akash, like the other, I mean, when you say like any other cloud that we
Mm-hmm.
use the different subnets over here, the VPC subnets is depend on the region itself. So when we create any subnet, the alternative when you create any VPC, so all the other subnets will be automatically created, or we have to create the manual itself on the other regions.
Okay, very good question. I would say, can you park this question or hold this question a bit? Because I'll just
Yeah.
explain in the demos, right? So that gives you a clarity. But to quickly answer your question, here in uh, GCP, when you are just creating VPC on a high level, it gives you a very good option to select known as auto. And if you select auto, you don't have to go and manually create your subnets. It entirely creates your entire set of subnets in all the regions, right? I will show you how that works also. Okay, I think then your question will be answered more accurately, right? Okay. Any other questions, or else we'll move on. Okay, just a humble request. Please be a bit more interactive. I guess that will also help me to gauge that you are understanding, and also you will also feel think that you are also understanding if that is fine for you. Okay, that's not an issue. Go ahead. Okay, So we can have that. So there was a pertinent question that how can we separate our public resources from private resources inside of VPC? That can be done with subnets, right? And also the another use of subnets over here is we can keep our resources across multiple regions for higher availability, right? Because this was one of the DevOps metrics that we also need to think of, right? That is the reason in the first class I spoke of the DevOps metrics, or the SLIs that we need to always keep in mind while we are designing anything in terms of DevOps, right? So now here you can just think of multiple metrics that are getting utilized, right? Availability of systems, it does answer to that. Again, latency is was one of the metrics. So if you're keeping your subnets or regions closer to your users or clients, then it covers your latency, then it covers your throughput. So that is how or why I just was telling you to focus a bit also on those topics, right, when you are learning that. Okay, quickly going ahead. Next we have a VPC. A quick example on VPC subnets is that resources in a, I just already told you, just a quick headline pointers out here is that we can create different subnets for public and private resources. Resources in a public subnet can be accessed from internet. I have already told you about that. And there is again another component attached to it. Why we can do that, I will also come to that in the individual thing. That's known as internet gateway. That is the reason why we can communicate to that. What is an internet gateway? I will let you know in upcoming slides, right? And apart from that, private subnet cannot be accessed from the internet, and but the public subnet can talk to your resource in private subnet, provided the proper privileges are given to that subnet, right? And I've already told you each subnet is created in a region. So if you're taking for an example, let's say VPC, then the VPC is a global resource, and then subnets will have its own regions. Let's see, as I already mentioned, US is Central one, Europe West one. This is the naming convention of regions that is followed in GCP. You might, if you have used other clouds, then other naming conventions might differ a bit, but the main concept still remains the same of related to regions and AZs, right? Okay, moving on. Okay, so you were asking about the question on if you are creating a VPC, do you again have to create your own subnets, right? That was the question, I think, if I get it correctly. So yes and no
Yes.
again to your answer. Yes. So yes and no again to your answer. So there are two ways that you can create your VPCs over here. So VPC does give you two options. One is the auto mode. I'll again show you also on next in the, I guess next only after this I'll do the practicals. So there's an auto mode and there is a custom mode, right? So what do I mean by auto mode and custom mode? Auto mode in an VPC VPC is when you are selecting auto mode, you don't have to take the hassle of creating the all the subnets in each particular region. So VPCs do directly automate that entire stuff for you, and you get a list of entire subnets sitting in entire regions that GCP does provide you, right? If GCP is now situated in 37 to 39 regions, if I'm not wrong, so you get a 37 list of subnets directly created for you, right? But there is again another option also given to you to have a more secured and systematic way of doing it. And so that is where the custom mode comes in. Custom mode means if you're selecting a custom mode, you have to select all the regions, the IP range. I will talk about IP range. That's again a very interesting thing. uh, so IP range are mainly known as CIDRs. So you have to select your CIDRs, IP ranges, and then yeah, this would be the predominant ones that you need to set it up, right? And also your regions where you want your subnets to get created. So what in other terms is if you're going for a custom mode, it gives you more control to your VPC network, right? And for your POCs, you can use auto mode network subnets. But if you're doing production, it's mostly recommended and also industry followed. Create your custom mode VPCs and not auto VPCs, because that's overutilization of resources, right? Okay, and just the two pointers when you're creating subnets is that please enable uh, private Google access. This allows VMs to communicate or connect to Google APIs using private subnets, because this keeps the data more integrated or more encrypted, because the APIs and the VMs or the resources will be communicating only on private IPs, because as I already told you, private IPs can only be seen inside your network and no one else outside can see it. So it gives you more security to it, but definitely there is a cost attached to it. Not much, but yeah, there is. And up from that, you also need to enable flow logs. But to enable flow logs, there is again, if you're doing POCs, you don't need much to enable this flow logs. What is flow logs? Flow logs is the entire communication, the traffic communication between all the resources that is going via your VPCs is stored in your cloud storage for you to track or for you to run any analytics on that. So for that reasons, or if you are facing any sort of issue, you can go back to those logs and do some track and trace, right? So that is the reason why, but it's a must when you're doing in a production scenario. Please do enable the flow logs so that you can, it helps you to troubleshoot, right? This will check. Okay, fine. I'll talk about CIDR post. I'll show you this quick demo. You can also do it along with me. It is absolutely fine. Or I am also open that if someone is sharing his or her screen, I can do it on their screen, so that uh, it is a live session for each and every one of you, right? And you get to have that feeling also if you're doing it for the first time. I am open to both ways. You can let me know which one is comfortable for you guys. Yes, no, maybe I do it. You would share your screen and I help you to do it. Whatever is fine. Anyone wants to go ahead?
Yep. Can I share my screen?
Yeah, yeah, go ahead. Do you have the permissions to share? I think no would be an answer.
Let me. No.
Yes, I have just escalated your privileges. Try now.
Yep.
Okay, your
Uh,
screen is visible to me. Okay, so if your everyone is following, one second, zoom in. Let me just quickly zoom into your screen. Okay, so if everyone is now following that, uh, Pritham is now on his VPC dashboard. And now, okay, there's one more thing that I also need to tell you is that unlike all other clouds, GCP does give you a default private network, right? So even if you are not aware of VPC, GCP does not stop you from creating resources. So you can use this default VPC to work along and go along creating your own resources, right? So just a quick overview on what is a default VPC. Default VPC is the same explanation that I already gave you, but again, you can see you have not created any subnets. So there are 37 subnets attached to this VPC, and then there is a MTU. MTU stands for maximum transmission unit. It's just basically how much amount of uh, uh, I would say basically how much amount of packet supported by your network layer, right? In terms of, let's say, header or data. This is up on a higher level, but if I explain you is, see, at the end of the day, it is IPs that are communicating, right? So IPs carry packets of data, right? If these terms is a bit critical or bit confusing, please do let me know and stop me so that I can also take lighter examples. So IPs do, and at the end of the day, there is IPs that are communicating, and those IPs are actually carrying packets of data, right, from one point to the another, right? It's basically doing hops from the one source to the destination, again picking up from that destination to another source to reaching your final destination, right? So this MTU is just a uh, units that you can tell your entire VPC that this is the maximum amount of data packets that you can transfer. Please don't go beyond this, right? So 1460 is a default number that is given to you, but based on your use case, you can definitely fine tune it more on that, right? Okay, and the mode used over here is auto, right? As I told you, there were two modes, auto and custom. So the mode over here used is auto, right? Please click on that default. Okay, just a quick overview is that please scroll down. This is a VPC that is given to you, and you can see the entire set of subnets attached to each particular regions, right? If you can see US Central one, you have your entire region list because this is an auto subnet. You get the entire 37 regions that we now GCP is across, right? You have your all those attached to it, right? And whenever you are spinning up your resources, you can select the VPC and then select the zone that region that you want to, and then you get that segregation of selecting your zones. If you want to use US Central one region, then you can definitely have go break down into US Central one's 5 zones, I guess they have. So that is where you can do that segregation. Okay, just take a look on. Apart from this, another thing is the IP ranges, right? So if you are using an auto, you don't have to give your IP ranges. GCP does take up free IPs that are given and assign those IP ranges to it. We will, I in the just next to it, we will speak about how this gets defined and how you also can do that definition, right? And there is again a gateway attached to it. Gateways are used for internal and external communication. We will talk about it, right? Just quickly come out of it and let's just quickly create a VPC. Okay, go to create, yes. Put a name to your VPC. You have to follow the naming conventions. Yes, this is allowed. So now you have to select, if you are using IPv6, then you have to have that enabled or disabled based on that. I think we will now work with IPv4 only. So let's not think about that. Yes, here is that specification that you need to make, whether you want to go ahead with the automatic one or you want to do a custom one. So we'll go ahead with both. Okay, first let's take a automatic. Click on automatic. Yes, so you can see the you don't have to have that now have that hassle of creating every region. GCP does that work for you. Scroll down and you can just go ahead and select create it, right? These firewalls and all whatever you are seeing, we will because we have not discussed, we will not take up much of your time right now. Just go ahead and select it, and just a pointer is that maximum transmission unit. That is where you can define that the maximum amount of packets that you want your VPC to uh, communicate or take up at one certain point of time, right? Let it get created. Likewise, go ahead and create one of your custom VPC. Put a name to it. Yes. Now comes the tricky part. Okay, not tricky, but if you're doing it first time, it might be a tricky. Put a name to your subnet. So these names would be should be a bit conventional when you're using in the industry. Please try to keep it thinking of the scope of your subnets. Like what I mean by scope is if you want to use those subnets for private related use case or public related use case, right? So think of if you want to use the subnet as private, keep it to private subnet 1 2 like that, or public if it is public 1 2 3, right? Okay, then very good. Pritam has selected the region that he wants to associate that subnet with. So yes, selected Asia South 1. Then the IP stack, which you will be working with IPv4. Just put a range to it. IPv4 range, you can put 10 dot. Yeah, that's fine. I'll explain it how you can do that. Come down and just yes, these were the two options that I was telling you. By default, if you are going with auto, the private Google access gets automatically enabled, and also the flow logs. We don't want it for now because we won't be communicating much with the APIs. And for flow logs, if you enable it, we have to also give it a cloud storage bucket where you want your flow logs to get stored, right? So yeah, please go ahead and create it. And apart from that, if you are wondering if I can select other subnets or create other subnets associated to it, there is again an option, add subnet. So if you want more than one region, you can go ahead and select another region and create it, right? For now, if you want, you can do it, or else let's skip that and create this private VPC, custom VPC. Yeah, hit on done. Okay, so your demo VPC has now got created, which was functioned on auto, and now your custom VPC is also getting created, right?
Yep.
Okay, very good. I think we don't have much time, but I'll quickly touch upon the CIDR ranges and then we can wrap up for today. Okay, I am quickly sharing my screen. I Do I have the permissions now? No. Can the admin team please give me the permissions to share? Can make me the presenter, please? Okay, I think they will rejoin. Preetham, are you able to do that? Make me a presenter. Okay,
Oh,
I
yes,
got
I
it.
did
Thank
that.
you.
Yep.
Thank you. I got that. Okay, and I need one more paint. Check. Okay, so is my screen visible, guys, to you? The PPT and the paint section?
Yep.
Yes, now maybe. Okay, good enough. So okay, so you were seeing that ranges, right? Which were already defined for a few subnets for you, and Preetham has also put a range to that, right? 10.2.0.0 slash 16 or slash whatever up to 32 you can put. So what was that? That was generally CIDR ranges, right? What do I mean by CIDR? CIDR stands for classless interdomain routing blocks, right? This term is a very heavy term, but this is, you don't have to memorize, just know this term. What CIDR stands for is a um, way of giving IP ranges to your subnets, right? Because end of the day, as I told you, your entire communication happens on IPs, right? So when you are setting up your resources, those resources should have an IP attached to it. And from where will it get those IPs? They will take those IPs from your subnets, right? And from where your subnets will know what IP to hold it, they will know it from your CIDR ranges that you define while you are creating it, right? So it is the range of addresses that you give to your network for your resources to use. This would be a very simplistic definition, right, to your CIDR blocks. Okay, now I let's think it in this way. We all know, I guess we all know 10.0 dot, writing a bit very slower. So if you want, you can also take up a notepad or a pen and a paper. That will help you to understand more what I am just quickly letting you know, because this is very intricate. 10.1 dots, let's take an arbitrary. So if you are talking about IPv4, so we generally see this kind of ranges, 10 dot series or 172 series or 192 series, right? And what do I mean by each bits that are out there? These are basically, let's think of 8 bits, right? What I mean by bits, 8 bits make up 1 byte. And in on a fundamental level, these are basically, if I talk about the first block, this is one octet, this is the second octet, this is the third octet, and this is the fourth octet. So what I mean by octet is it has a 8-bit series, right? So that is the reason I was I've opened paint for you. It's easier, make you understand. How can I do that? Okay. So if this is one, I have to write it down. Please pay a bit attention to this concept. This is very important. So I might take a bit of time to write that, but please bear with me. So as I was telling you, these are octets, right? So as we work with IPv4, I have 4 octets, and 4 octets make up total of 32 bits, right? So if I let's take example of the first octet. Oh, sorry, we basically start from here. So if this is the first octet, what I mean by that is this is now segregated into 8 small bits, right? I'm just not drawing all. There will be 1, 2, 3, 4 up till 8. Okay. Likewise, again, we will have the same 8 bits over here too. And again, same over here. Please take a note, pen and a paper, and just try to create this 4 blocks and draw 8 lines, small blocks in each block, right? Okay, now because I am taking off bits and octet, and this entire block is of 32 bits, right? So each one stands in the series of 2 to the power, right? So this first one is of 2 to the power 0, next is 2 to the power 1, the next would be 2 to the power 2, 2 to the power 3, and it comes up to 2 to the power of 8, and right. So this is how these, because our computers only understand 0 and 1. You writing 10 as a whole number over here does not mean that the input going to your interpreter or your compiler or your system is 10. It is basically 0 and 1, right? So if I mean 10 over here, so what do I mean by that? You have to use this octet to create a 10 in the thinking of the series, because we work with binaries. So binary series is we think of 2 to the power, right? So if I want to make a 10 out of it, so we have to make it, let's say 10 would be, this would be 1, this would be a 0, 2 to the power 1, and 6, right? 8 is 1. So please do along with me also. Don't only keep me into it. Yes. So maybe, yes, would be a 0. Where is the eraser? I think we are done. Yes. One. So this is 2 to the power 2 is 2, 2 to the power 3, 2 is 4. So here also we need to keep a 0. 2 to the power 3 is 8. So we'll keep a 1. So that makes up 10. And for the rest of the blocks, we will put zeros. So that is how my system understands. Okay, I got a 10 as a number. So how do you change it to binaries? So here is how they do that. And then this is formed, right? This also has a greater significance when I just elaborate more. But first you need to understand this, how this first part is made, right? Using 0 and 1, right? Are you with me up to this? Okay, if you just think of the others will be, because it is having a 0, so you don't have to think much of it. So all 8 bits in this octet will be 0 because it has a 1. So 2 to the power 0 is basically 1. So you will have 1 to that, and the entire other 7 bits will be 0. And again, you have a 0, so you don't have to think much. So it will be all zeros. Are you with me up till now? If any understanding issue is there, please let me know. Please don't feel shy, guys, because we are all here to learn, right? And these concepts are, I guess, has to go in, because these would be asked wherever you go. Not even asking you, you should know this, right? Yeah. Any questions? I think we have gone beyond the time for today. We will park for today up till here, but if you have questions, I'm open to it. Any question, guys? Hello.
Nothing from that.
So, Akash, like coming to the VPC network, like what kind of failures we can expect once the process is going on?
Sorry. Wait, what
And
kind of?
in VPC network, I'm talking about.
Mhm.
So, what kind of failures we can expect, and how we should resolve those?
Okay. Okay. Understood. Okay. Okay. I can give you a very quick example of what kind of major failures that we definitely see. Okay. There are
Okay.
multiples. We'll as we go along. But to the definition that to the explanations that I gave you up till today, is
Mhm.
there is one thing to it, right? That is the reason why I was explaining you this CIDR ranges. Just take an example of this, right? This IP ranges which you see, right? This is a CIDR block. Okay. Let's say for US Central one, this is a CIDR block of 20, right?
Are you
You will
sharing the
understand
screen?
it. Oh, you're not able to see it, is it? Okay, okay.
No.
Hold on,
Yeah.
hold on. Yeah, yeah. Yes, I am into
Okay.
the GCP console. Okay.
Yes.
So
Yeah.
this is a typical default VPC block. Okay. And this
Hmm.
VPC block has a typical, not typical, this is the subnet is again assigned with a IP CIDR block, right? This is from where
Hmm.
your resources get your IPs, correct? Up till there
Yeah.
you are fine, right? So that is the reason why I was explaining you and how you can gauge these things. Okay, now what issue you can face is, you can see it has a range of block of 20, right? So let's forget 20 for now. I'm just giving an upper level example. Let's say this US Central 1 region subnet has 30 IPs to be utilized. Okay. Now
Yeah.
you, for this region, you are wanting to, means scale up your resources. Let's say you have now 30 resources to be newly created, but you only have 20 IPs to utilize. Okay. So you cannot work with this region anymore because you have already exhausted your list of IPs. So now when you try to spin up your VMs or other resources, those will not have their IPs, and as a result, they will fail, right? Or else, what can also happen, another scenario is, let's say you are using a auto scaling type of a scenario, and now again the same issue has arisen. You have, let's say, last 5 IPs, but again due to the auto scaling group, it has scaled up to 10 more instances, but it can only take up 5 instances, but the other 5 will never come up because you have exhausted your IP ranges, right? These are the typical scenarios that you problems that you face if you are not defining your CIDR blocks correctly when you are setting up your subnets. Because when you this should have the bandwidth to cater your load, right? When you're thinking of production load, you need to think of your design side of it also. You are with me up till now, right? You have
Yeah,
understood the example. Yeah.
yeah.
So that is the reason why I was trying to explain you. You need to understand this. This is, I will tell you, in this industry, not much people are aware of this, how these ranges are defined. Okay. They just blindly just see it. Okay, okay, okay. This is where it comes up. No, there are certain nitty-gritties that you need to follow when you're defining a public subnet. What should be the amount of ranges that you give it to them, and how do you also think of when you're defining a private subnet? Because these I have also witnessed it not getting defined properly, and we have these hassles in the modern industry. And then again, there are multiple downtime, and then we have to fix it, and the fixing it is also a bit trickier, I would say, and there's a lot of hassle that goes in. So in the first go itself, we need to define it properly.
Okay.
Okay. Yeah. Any other question?
Akash, Akash,
Yeah, go ahead.
can we scale up that VPC range?
Yes, you cannot directly scale up this VPC range. uh, I'll show you there's another way of doing it. Okay, if I am just into this only, there are two ways to do this. First is, if I go into this, it is an auto. Will it allow me? See, yes, there are two ways of doing it. First is you increasing the bandwidth of this, right? You change the CIDR blocks from 20 to 16, so that gives you a more bandwidth. Okay, what is 2016? We will see into the next session. Another is if you want to add other IP ranges, you think that this series has come to most of exhaustion, you can add secondary CIDR blocks again to it, right? So this advantage is more, instead of because if you are setting it over here, you need to reboot all most of your systems that are running, right? So that is also at par with your subnet. But if you are using newer subnet ranges, then your new resources will directly take this up, right? And you don't have to much of reboot this. Yes, so this is how where you can do that.
Okay, so the
But this
scaling
is
up the
this is
VPC side is not an online activity. You meant to say.
no, it is
It
an
requires a
online
downtime.
activity. No, sorry.
It requires a downtime. You said to scale up these ranges, a few reboots has been required.
Yes, if you are doing it on the same IP ranges, or if you are exhausted and your resources got stuck, then definitely there is a downtime, because your new resources will never come up until you define a bigger, broader range to it. And you also need to somewhat, if it is getting stuck, you need to do a reboot of your existing infra to some extent. Yes.
Okay. And the secondary IP would be the different range or would be the same range or any.
No, different range, right? Different range. That is the why they have given you this added advantage,
Okay.
right? If you have another range to give, another series, if you want, you can use this.
Okay.
Any other question, guys? Or else we will uh, park the session for here.
Sure, yeah. That's it we have.
Okay, cool. uh, so maybe we connect tomorrow. Thanks a lot everyone for your time. Bye bye. Have a good
Yeah.
great day ahead.
Thank you so much. Yeah. Bye bye.
Yeah.
Thank you.